Imagine this, your GPS suddenly lost track and your phone signal disappears, but the weather looks perfect. What if I told you that your GPS isn't drifting on the ground but it's being tossed by the invisible phenomenon above? Ladies and gentlemen, our Earth's atmosphere consists of 5 layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. These layers are distinguished by changes in temperature, pressure, and gas composition. Within the thermosphere lies the ionosphere, a region filled with charged particles produced by the sun's radiation. This layer might look calm, but is actually full of invisible storms. In fact, this stormy layer once marked in history. During a battle known as Operation Anaconda in Afghanistan 2002, US military forces experienced severe radio communication failures, somehow because of the disturbances in the ionosphere known as plasma bubbles. These bubbles disrupt radio waves, limiting coordination and affecting mission effectiveness. That's how powerful and unpredictable our upper atmosphere can be. When these plasma bubbles form, they create ionospheric scintillation, a condition where radio signals from satellites become distorted, just like how light bends through wavy water. For most people, this means slow internet or inaccurate GPS readings. But for pilots, ships, and rescue teams, these disruptions can be critical. Before this research, scientists measured such disturbances using radar, ionoson, and sky images. However, those instruments cover only a small region, often just one station, and provide low spatial resolution of data. In this research, we filled this gap using Global Positioning System or GPS data. With more than 100 GPS receivers across Southeast Asia, we can monitor the ionosphere in a much wider and denser coverage, allowing us to detect plasma bubbles more effectively and understand their behavior under different geomagnetic conditions, quiet and active days. As a result, we can also understand and prepare for the growing impact of severe space weather events. Recently, in 2024, the National Oceanic and Atmospheric Administration, NOAA, reported over $20 billion in damage from severe storms in the United States, showing just how costly atmospheric disturbances can be when we are unprepared. By studying how space weather affects our communication systems, we can build better monitoring and early warning systems, helping pilots, sailors, and even everyday users like you and me stay connected when the sky turns unpredictable. So the next time your GPS gets confused, remember, it's not your phone's fault. It's the sky having the storm.